Our next guest, Dr. Nazneen Virji-Babul, PhD in neuroscience, is an associate professor in the Department of Physical Therapy, Faculty of Medicine, and senior advisor to the Provost on Women and Gender Diverse Faculty at the University of British Columbia, Vancouver, Canada. Her research addresses fundamental aspects of brain behavior relationships in typical and atypical development.
So my research, what I do is I study babies. I want to understand how babies learn, what they think about, how do they actually understand the actions, the emotions, the intents of other people. How can we figure this out? Young babies can't talk, they can't tell us what they're thinking. So how do we actually understand what babies can think about? Almost 50 years ago, we used to think that babies were born as blank slates, that they were just really just blobs that came into this world, that they slept a lot, they cried a lot, they pooped a lot, and if the parents were lucky, they smiled at them every now and then. And we thought that, it was coming through and being part of life that actually helped them to learn things. We now know that that's completely untrue. This is part of the debate about nature versus nurture. We now know that babies are actually, they're like little scientists in training. They can perceive their environments, they understand patterns, they are born being able to understand any language that exists in the world. And they actually can detect patterns in the environment. They can actually understand simple math. When they're given tasks, when we ask babies to do things or to look at things where things aren't quite the way they should be, they frown, they give us some ideas that they actually understand patterns in the world around them. What I'm interested in understanding is, how do babies learn about emotions? How do they learn about actions? How do they learn about empathy? And how can we tell that when a baby is just a few months old? So what I do is I use some very specialized equipment called EEG. And this EEG comes as a form of a cap. I put this cap on there, which has electrodes on it. And what the electrodes do is that they actually can record signals from the brain that's underneath the skull. And by analyzing the patterns, these patterns that are in their brain, I actually get a glimpse into what's happening inside their brain. And I can understand what it is that they're actually thinking about and how they're learning as time goes on. So one of the things that I'm really interested in is about the perception of emotions, the perception of intentions. And there's one discovery that was made quite by accident about 10 or 20 years ago by an Italian neuroscientist. And he was studying how monkeys actually learn to control their movements. So he had monkeys in a chair similar to how I'm sitting, but their hands were strapped down. And he opened up their skull, and he had some electrodes, and he put them on the brain to actually record the signals of the brain while the monkey was making certain kind of movements. And at one point, just by coincidence, one of his graduate students walked into the lab, and the graduate student had a banana, and he started peeling the banana and started eating it. And amazingly, the monkey who was sitting there, the neurons, the cells in his brain that actually are related to movement, started firing. They started firing while he was watching this person eat a banana. And he wasn't doing anything. He was strapped down by the chair. And so by accident, we discovered that there are specialized neurons in our brain that actually respond to other people's actions, other people's emotions, and other people's intentions. And we are actually, it seems like we are born with these neurons, and they get refined over experience. So there's a lot of things that are happening in neuroscience. There's just an explosion right now. It's one of the areas where we're starting to see input from cognitive psychologists, from people who do physics, engineering. There's a big push towards cognitive neuroscience. And all of this has helped us to get neuroimaging tools that are giving us finer and finer details and information about what exactly is going on in the brain. There's two things that I specifically want to highlight. One is that we used to think that all of the development in the brain kind of was completed by the age of, say, 5 or 6. This is why we have a big push on early childhood development, on the 0 to 5 sort of age range. But we now know that the human brain actually is not completed in its development until the late 20s and even early 30s. And it may surprise you that development goes on so far. From puberty to about the age of late 20s is the second most dynamic period of brain development. There's an explosion in social emotional development. And that's something we're just learning about, that this second explosion of development is actually really spectacular. And it's also a time where parents really need to be involved in their child's development, because this is a time when the kids are actually like sponges. They are absorbing so much new information. And the fact that they are surrounded right now by social media, by their peers, they're getting information from lots of different sources, that their brain is trying to make sense of that. And they're also at a stage where the information about their social development is much more heightened. They're influenced a lot by risk taking, for example. And so there is almost a disconnect between the brain's development for social emotional kinds of development compared to their cognitive development. So their cognitive development is actually a little bit slower in pace compared to these other regions. These are the areas that actually help them to get to their next stage of development. And what we're learning about this from some of the neuroimaging is that we can now actually see these changes that are happening both in terms of the structure and function. We can see the changes that are happening and how they're increasing, how certain tracks are increasing in their volume, for instance, how the networks are becoming much more complex and integrated. So no matter what the task is, the entire brain is communicating. Different parts of the brain are communicating with each other. So those are the two most important things that are happening right now in the field. So I think that, to the parents, what I would say is, don't impose your ideas on what you think your children should do. Just give them lots of different opportunities to experience different things, whether it's in the arts, whether it's in music, whether it's in science. Just seek out all these opportunities and give them those experiences. For students, they often feel very shy about approaching professors when they're at the university. And I get a lot of students at the first day of class. This year, of course, is very different, who are lining up outside my door asking for any kind of internships or volunteer work, just to understand how does the lab work? What sort of experiments are you doing? Can I get involved in that? I think it's really important that people who want to go into the sciences or into any kind of academics, that they need to get experience of what that actually feels like. What does it look like? What does it mean to do some work in a lab of somebody, one of the professors? So I would really suggest that you try and get that students or whoever is interested in this to go and approach the professors. Most of them would love to talk about their work. In fact, you have a hard time getting them to stop talking about their work. And they are usually very willing to have undergraduate students come and observe what's going on, or if they think you're actually good enough, then they will invite you to come in their lab. And by going to different labs, students will get an idea of what's actually out there. They'll get hands-on experience and get to really see what are the new fields out there. What sort of new and exciting work is being done that they would be interested in getting involved in. It's very different from just reading papers and thinking theoretically and talking to people. Once I find when students come into my lab and actually have to put on an EEG cap on an infant and then look at the brain signals afterwards, seeing that in real time, trying to analyze those signals, they start to understand the process of what research is all about, what science is all about. It's not about the scientific method that they learn about in high school. It's much more dynamic. It's very active, and it involves a lot of creativity. And I think a lot of students don't realize that when they're thinking about careers in science. When you have fulfilled your goals and you've become a leader in your field, remember that you also have to give back and be a mentor or a sponsor to somebody else to make sure that the next generation is going up. Do not let anybody hold you back. As Ruth Bader Ginsburg has said, speak your mind, even if your voice quivers. And I want to tell this to all the girls and all the women who are listening to this.